We're going to start with a very easy and a thing that you have already seen in your earlier classes, indices, also famously known as exponent. So when I say indices or exponent comes from the word index. Index means power. So in this particular topic, we are only going to discuss about star terms that looks like something raised to the power something. That is, say 2 to the power 3, 5 raised to the power 2, a raised to the power b. So we are going to deal with situations that looks like these. So when I say 2 raised to the power 3, that means you are supposed to multiply 2 three times. When I say 5 power 2, I mean that we need to multiply 5 2 times. Now, when I say a raised to the power n, what do I mean? I need to multiply a. How many number of times? N times. Yes. So, entire chapter we are going to discuss with terms that looks like a raised to the power n. So there are several formulas and several things that revolves around this, and we are going to start with those formulas. First, anything raised to the power 0. That means we need to multiply a 0 times. That means I don't even need to multiply anything. So if I'm not writing anything, so the blank vacant space will be filled up by what? 1. So anything raised to the power 0 will give us 1. For example, if I say 2 to the power 0, I say 3 power 0, I say x power 0, anything to the power 0 will give us an answer
1.
1. If I would have given you xy squared to the power 0, even then the answer would be 1. Anything raised to the power 0 will be 1. A plus b whole to the power 0, again it will be 1. So the first formula is any number raised to the power 0 is going to give you an answer 1. Clear?
Yes, ma'am.
Let me know as soon as you have a doubt, okay? Second, same base, multiply. Example, 2 power 4 multiplied by 2 power 7. So we have two index, two exponent questions, and both of them have the same base 2, right? Both of them have the same base 2 and getting multiplied. So the answer will also have the same base. What we will do is we are going to add the power. So this will become 4 plus 7. So answer would be 2 power 11. If I have 3 power 2 multiplied by 3 power 3, what will I get?
3 power 5.
3 power 2 plus 3, that is 3 power 5. So the formula a power m multiplied by a power n will give me the answer
A power m plus power mn.
a to the power n plus n. Yes?
Yes,
Is it
ma'am.
clear? Next, same base. This time it was getting multiplied. Now what will happen is the same terms are getting now divided. A power m divided by a power n. For example, if I have 5 power 6 divided by 5 power 2, in the numerator 5 is getting multiplied 6 times, and in my denominator 5 is getting multiplied 2 times. So the net answer will be 5 gets multiplied 6 minus 2. 2 comes above. What happens? See, if I don't know the formula, what will happen? Here I have 5, 6 number of times. And here I have 5 2 times. So 2 5s gets cancelled. So 5 to the power 4. 4 5s remain. So same thing could be visualized as 5 power 6. When 2 from the denominator comes to the numerator, changes its sign. The sign only gets changed for the power. So sign changes of the power and it becomes minus 2. So this will become 5 raised to the power 4. Yes?
Yes, ma'am.
Yes, ma'am.
Yes,
So
ma'am.
here a power m divided upon a power n. So bases are same and they are getting divided. So the powers will get subtracted. So now my answer would look like,
A power m minus n. A power
a
m
to the
minus
power
A
n
power
minus.
n minus n.
Yes. If I would have given 10 to the power 4 upon 10 power 3, answer?
10 power 1.
10 power 1,
10
ma'am.
power 1. Yes.
Perfect. Any doubts still here?
No, ma'am.
No, ma'am.
So the
No,
first
ma'am.
formula said anything raised to the power 0 will be
1. 1.
a same base
1.
multiply, power are gonna get added. Same base divide, power are gonna get subtracted. Clear?
Yes, ma'am. Yes.
Any doubts?
Yes, ma'am. No, ma'am.
No, ma'am.
Next, fourth. If I have a power m and there is another number on the same level. See, there are two things now. Understand. First example, 2 to the power 3 that gets multiplied twice. So here if you can see the font size of 3 and 2 are same. That means they are in the same floor. 2 is in the ground floor. Both 3 and 2 are in the first floor. But if you look at this question, 2 raised to the power 3 raised power 2. If you now see, can you not see three different floors? Ground floor 2, first floor 3, second floor 2. Yes?
Yes, ma'am.
So what I'm talking about is this scenario. When there are two powers in the same floor. So what will happen is they'll get multiplied. What is going on here? 2 cube into 2 cube into 2 cube. So applying the second formula, same base multiply power are going to get added. So what will I get? 3 plus 3 plus, sorry, 2 times only. No? So what will I get?
2 power 6.
Here
2
also 3
power
into 2 is 6. So if there are two powers on the same floor, they are going to get multiplied and we are going to get 2 power 6. Yes?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So here what will I write? A to the power m into n. A to the power m into n. Since m and n were both on the same floors, they got multiplied. Yes?
Yes, ma'am.
Yes, ma'am.
But in this case, where there are three floors, so the demolition always starts from the top. We can't tear down the entire ground floor, the base part first, right? So here also the demolition will start from the top floor. So we'll first solve the first top two floors. So our top two floors are 3 square. Our top two floors are 3 square.
Yes, ma'am.
So what is 3 square?
9.
9.
So 2 to the power 9. So the first
Yes,
floor and second floor, when calculated, gives us 9. So that takes the place of the first floor. Yes?
ma'am.
And then
Yes.
we can calculate this to 512. Clear?
Ma'am.
Yes, ma'am.
Suppose I tell you 625 raised to the power 4 raised to the power half. What will happen? One second. Raised to the power. Okay, fine. What will happen?
5 power 4.
Our
The whole to the power 4.
See, first calculate this because there are three different floors. So calculate the top two floors first. What will you get if you
cancel.
calculate 4 power half?
It,
4 can be written as
2 square. 2 square.
now
The
2
whole
and
power
half are same floor. They'll get multiplied and we are left with.
2.
So now the top two floors when simplified gives us 2. Yes?
Yes, ma'am.
Everybody clear?
Yes.
Yes, ma'am.
Yes, ma'am.
25 square.
Now we don't need now.
Yes, ma'am.
You can write here 5 to the power what? 4. So this will become 5 to the power
2.
no. Why 2?
8,
5 to
ma'am.
the power 8.
8, ma'am.
8. 5 to the power 8.
This we won't calculate. We don't go above 5 powers. We calculate only till 4, 5 powers. We don't calculate above that, except for the number 2. Done?
Yes, ma'am.
Yes.
So the first property, anything raised to the power 0 is 1. Second property, same base multiply power add. Third property, same base divide power minus. Fourth property, if the numbers are on the same floor, they can get multiplied. If there are 2 different floors, we start the solving from the top 2 floors. Yes?
Yes, ma'am.
Yes, ma'am.
Now, the fifth property. If I have A into B whole power M, I can open the bracket and give this power to both of them. So it will become A to the power M multiplied by B power M.
Yes, ma'am.
Same thing can
Yes.
also happen in division. A by B whole power M. This will become A raised to the power M divided by B raised to the power M. So if I want to use this, for example, if I have 81x to the power 8 whole to the power 1 by 4. Let's try and simplify. First, 81 can be written as
3 to the power 4.
3 power 4.
3 to the power 4.
Now, if I open the bracket and apply this property, this 1 by 4 will be provided to both the numbers.
Yes, ma'am.
Yes?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Now applying the fourth property. Here 4 and 1 by 4 are in the same floor. So they'll get multiplied and we are left with only 3 power 1.
Yes, ma'am.
Here 8 and 4 will get simplified and we are left with
X power 2.
final answer is 3x square.
Yes, ma'am.
Guys, any doubt?
No, ma'am.
No, ma'am.
Suppose if I tell you 9x power 4, y power 6, whole power 1 by 2. Will you try?
Yes, ma'am.
Yes, ma'am.
You should not have taken so much of time. Answer?
Ma'am, 9x squared by y cube.
No. 9 can be written as 3 square. Now, when I open the bracket, this half will be given to everyone. This half will be given to everyone. Is this clear?
Yes, ma'am.
Now,
Yes,
if
ma'am.
I simplify, 2 and half gets cancelled, we have 3. 4 and half gets cancelled, we have x square. 6 and half gets cancelled, we have y power 3. Is it clear? This is our final answer.
Yes, ma'am.
Yes. Yes, ma'am.
Did you understand, everyone?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Next, seventh property. Seventh property. It says that if a number has a negative power, if a number has a negative power, so what we can do is shift its location. Right now, my number is in the numerator. If I bring it down to the denominator, what will happen is the only thing that is going to change is the sign of the exponent. So, right numerator m was negative. So, if I bring it to the denominator, the sign of the exponent m will become positive. So, it will become a power plus n. Nothing in the numerator. So, 1. If I have, for example, 3x power minus 4, 16x power minus 4 to the power half, right? So 16 to the power half, x power minus 4 to the power half. 16 can be written as
4 square.
so that's half. Here 4 and 2 gets cancelled, so I'm left with minus 2. Here 2 and half gets cancelled, I'm left with 4. We never leave our answer with a negative power. So what will happen? 4 was fine. 4 did not have a power, so the power is 1. But x power negative 2 cannot be there in the numerator because it has a negative power. So in order to make the power positive, what will I do? I'll bring it down to the denominator. So x power minus 2 in the numerator becomes in the denominator
X square, ma'am.
X square.
X square, ma'am.
clear. It could have been the other way around also. If you had 3 by x power minus 2, the power is negative. I can bring it to the numerator and make the power positive. So it will become 3x square. It will become 3x square. Yes?
Yes, ma'am.
Yes, ma'am.
So whenever you shift a number from numerator to denominator or vice versa, only the sign of the power changes, nothing else. Clear?
Yes. Yes.
Yes, ma'am.
8. Nth root of a. Nth root of a. Whenever I want to remove the root over and want to simplify, what will happen is this n will come in the exponent, but as a reciprocal. Nth root means the power is 1 upon n. 1 upon n. For example, if I tell you cube root 27, if I remove the cube root sign, then what will be there in the power?
1 by 3,
1
ma'am.
by 3.
And now in
1 by
order
3.
to simplify, 27 can be written as
3 the whole cube.
3.
so now 3 and 1 by 3 gets cancelled. The final answer is 3.
3.
If I would have given you 6th root of 64, what will happen here?
64 to the whole power 1 by 6.
Then
2 power 6, the whole power 1 by 6.
perfect. Then 6 and 1 by 6 gets cancelled. Final answer.
2.
Any doubts?
No, ma'am.
No, ma'am.
Anyone has
No.
any doubts,
No,
guys?
No, ma'am.
No, ma'am.
Next, 9. This property gets very handy, becomes very handy when we have equation solving. For example, if I have x cube equal 125. So whenever I have a situation of this sort and I want to shift the power from one side to other, from one of the side to the other side, what will happen is it becomes a reciprocal. So here I had n. When it goes to the other side, it will become reciprocal. So 1 by n. Or if I had c power 1 by n equal d. So when I send 1 by n power to the other end, it will become reciprocal and it will give me an answer d to the power n. Yes?
Yes, ma'am. Yes, ma'am.
In this scenario, if I want to find x, I want to leave x alone. So power 3 goes to the other side and it will become
125, the whole power 1 by 3.
perfect. Now 125 can be written as
5 cube to the whole power 1 by 3.
3 gets cancelled. So answer
Fine.
is 5. Any doubts?
No, ma'am.
No, ma'am.
No, ma'am.
10th. We could have used this in the above example also. If there are two sides and both of them have the same power, I can cancel or equate rather that the base also has to be same. Since the powers are same and the two terms in whole are same, that means their bases also have to be same. For example, the same here. X cube is 125. I can write 125 as 5 cube.
Yes,
Ma'am.
So the powers are same. So I can conclude this as
X is equal to 5.
X is equal to 5.
clear.
Yes, ma'am.
Yes, ma'am.
Everybody clear?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Similarly, if your base are same, for example, 2 to the power x equals 64. What can I write here? This is 2 power something. So can I not write 64 also as 2 to the power something?
Yes, ma'am.
What can I do?
2 power 6.
6, ma'am.
So what will I get now if I compare?
X
X
is
is
equal to
equal
6.
to 6.
That is what the properties also. Bases are already same. So what can I write? The number, the powers, the exponents also have to be same. Clear?
Yes, ma'am.
Yes, ma'am.
Yes,
So
ma'am.
the first property that we talked about was anything raised to the power 0 is 1. Second property that we talked about, same base multiply power add. Third, same base divide power will get subtracted. If I open the bracket, the power is going to everyone. If I divide, if I it's a division, then also if I open the bracket, the power goes to each and every term. When you're shifting a power from one side to another, it gets reciprocal. When you shift a number from numerator to denominator or vice versa, the sign of the power gets changed. Yes, and here the equating part. Any doubt till here?
No, ma'am.
No, ma'am.
No,
No,
ma'am.
No, ma'am.
Everybody clear?
Yes.
Yes, ma'am.
Let's do a couple of questions now. Let's see. Question 3x power 4 y power 3 divided by 18 x power 3 y power 5. So numbers will be dealt in themselves. So we can cancel 3 ones are 3 6 are. So denominator gets a 6. Now with the variables, same base, they are getting divided. So the power will get subtracted. What will I get
Yes, ma'am. X power 1.
in the
X
numerator?
power.
Is it okay? Now for y, you can think in two scenarios. Y, if you are bringing down 5 above, this will be the scenario. So x y power minus 2. But we can't have the answer with a negative power. What will we do?
Bring it to the denominator.
Bring y
Bring
cube
it to
to
down, ma'am.
So
denominator.
y power minus 2 will be brought down to the denominator to give me a final answer as.
X by 6y square.
So in order to avoid this, what we could have done is, so 3 and 6 got cancelled. 4 minus 3, 6. I would have taken the smaller number 3 to the denominator. 5 minus 3. Whoever shifts, whoever loses the location gets negative. So earlier here, 5 was brought down from denominator to numerator. So 5 changed the sign. Here I brought down 3 from the numerator to denominator. So 3 changed the sign. Whoever goes from one place to another will change the sign. Clear?
Yes, ma'am.
So x power 1, 6 y square. Clear?
Yes,
Yes,
ma'am.
ma'am.
Yes.
Any doubt?
No, ma'am.
No, ma'am.
No,
No,
ma'am.
ma'am.
Question. (28) x cube 4 to the 4 x power minus 4 This is y square, this is y cube. What will happen here? 4 and 28 gets cancelled. So 7. Now in x, which number will you change? Will you bring -4 to the numerator or you'll take down 3 to the denominator?
-4 to the
-4 to the denominator.
Minus
Already
4
had
to the
3.
numerator.
In the denominator, it was -4. When it comes to the numerator, it will become.
+4.
Plus 4.
Now for y, where should I take it, to the numerator or the denominator?
Denominator.
Denominator.
So what will it become?
Y power 1.
3 minus 2, because 2 is shifting, so that gets negative. So 7 x power 7 y power 1. Any doubt?
No, ma'am.
No, ma'am.
No, ma'am.
All of you clear?
Yes, ma'am.
Yes, ma'am.
Try. -2x square y cube whole to the power 3. You should have been quick.
Ma'am, -8 x to the power 6 by y to the power 9.
Perfect. So the power will be given to everyone. Same floor, so it gets multiplied. -2 multiplied 3 times will give me -8. X, 2 and 3 gets multiplied will give me 6. 3 and 3 gets multiplied, it will give me 9. Yes?
Yes.
Yes, ma'am.
Any doubts?
No, ma'am.
No, ma'am.
No, ma'am.
Question. Cube root 27 power -2.
Ma'am, 1 by 9.
Very good. First, let us remove the root over. When we remove the root over, it gets reciprocal. So -2 and 1 by 3 gets multiplied to give me -2 by 3. Now, 27 can be written as 3 cube. They are all in the same floor, so 3 and 3 gets multiplied. I'm left with 3 power -2. I can't have negative power. So what will I do? I'll bring it to the denominator. So the power will become positive. Numerator, I can write 1. So answer is 1 upon 9. Yes?
Yes,
Yes.
ma'am.
Yes, ma'am.
Anyone else is not
Yes,
able
ma'am.
to do the sums or getting stuck? Any problem?
No, ma'am.
No, ma'am.
Question. 625 to the power -1 by 2 to the power -1 by 4 whole to the power 2. By looking at the question, can you see that -1/2 minus 1 by 4, and 2. Are they on the same floor or different floors? Are they on the same floors or different floors?
Same.
Same
Same
floor.
Same
floors.
floor.
So if they are in the same floors, all the powers will get multiplied. So what will we get? Multiply all the powers.
From 1 by 4.
Plus 1 by 4. Yes?
Yes, ma'am.
Now 625 can be written as
5
5
to the
plus
power
4.
4.
5 power 4. Now 4 and 1 by 4 when multiplied gets cancelled out. So the answer would be
5.
Why, ma'am?
clear.
Yes, ma'am.
Yes,
Ma'am.
Any doubt?
No, ma'am.
Suppose the question is 256 to the power minus 4 to the power minus 3 by 2. How many floors are we talking about? How many floors are we talking about?
3 floors.
3 floors. So what do we do in such a scenario?
Multiply the first and second floor.
No, not multiply, solve. Solve them first. So when I'm going to start my simplification, I'll first solve this. Get the answer here. Solve this. Four can be written as 2 square. 2 gets cancelled. So 2 power minus 3. So in order to remove the negative sign of the power, I can bring it to the denominator. So here the answer is 1 upon 8. For the first floor and the second floor, the answer is 1 upon 8. Any doubt?
No, ma'am.
No, ma'am.
No, ma'am.
Now I'm going to write the question again. And I'm going to put the value in the first floor and second floor. So instead of that, I can write the minus sign was there. Here I can write 1 by 8. So now we are left with ground floor and first floor, only 2 floors.
Yes, ma'am.
Yes, ma'am.
So
Yes, ma'am.
256 can be written as
2 to the power 8.
2 to the power 8.
Sorry.
so now 8 and 1 by 8 gets cancelled. We are left with 2 power minus 1.
Yes, ma'am. Equal
So
to
2
1 by
power
2.
minus 1 will be
1 by 2.
1 by
1 by
2.
2. Any doubts?
No, ma'am.
No.
See, right now we're writing too many steps. Once you get comfortable, you can skip a few steps. Not a problem.
Okay, ma'am.
Okay.
Everyone done?
Yes, ma'am.
Yes.
Yes,
Yes,
ma'am.
Can I increase the level a little?
yes, ma'am.
Try. 81 to the by 16 whole power minus 3 by 4 multiplied by 25 by 9 whole power minus 3 by 2 divided by 5 by 2 raised to the power minus 3. Try.
Ma'am, is it 1?
Yes. So first let's simplify this. This is 3 power 4, 2 to the power 4. So if I open the bracket, 4 gets cancelled. 3 power minus 3, 2 power minus 3. We can't have negative powers. So 2 power minus 3 comes to the numerator and 3 power minus 3 goes to the denominator. Is this simplification okay? Is it okay,
Yes,
guys?
Yes, ma'am.
Yes, ma'am.
Let's simplify inside. This is 5 square and 3 square minus 3 by 2. If I open the bracket, both of them will get minus 3 by 2. Here I'll have 5 power minus 3, 3 power minus 3. Now divided by 5 power minus 3, 2 power minus 3. Bringing them up, changing their position to make their powers positive. Now from division to multiplication, the terms changes their location, they get reciprocal. Any problem till here?
no, ma'am.
No,
No,
ma'am.
ma'am.
Now again they will change their position. Rest all at their places. So now 3 cube gets cancelled. 2 cube gets cancelled. 5 cube gets cancelled. So the answer would be 1. Answer would be 1.
Ma'am.
Yes, ma'am.
Yes?
Yes, ma'am.
Anyone has any doubt?
No, ma'am.
No, ma'am.
No, ma'am.
Try. 4 upon 216 to the power minus 2 by 3. 1 upon 256 to the power minus 3 by 4 plus 2 upon 243 to the power minus 1 by 5. Right. Guys, answer.
214.
Very good. Rest of you. See, first, the numbers can come to the numerator. You can simplify them there also, any which way. So 216 power plus 2 by 3. 256 to the power plus 3 by 4. 2 into 243 to the power plus 1 by 5. Now, 216 can be written as 6 cube. 256 can be written as 2 power 8. And 243 can be written as 3 power 5. Any doubts still here?
No, ma'am.
No, ma'am.
Now, 4. 3 and 3 gets cancelled. 6 square. 2. 4 and 8 gets cancelled. So 2 into 3, 6 plus 2 into 3 power 1. Yes? So 4 into 36, 144. 2 power 6, 64. 3 into 2, 6. If I add them, I get 214. Does anyone have any doubts?
No, ma'am.
Ma'am.
No, ma'am.
Next. 1 by 4 whole power minus 2 minus 3 into 8 to the power 2 by 3, 4 power 0 plus 9 by 16 to the power minus 1 by 2. Try. you have an answer?
Ma'am, 5, 1/3.
Now, 1 by 4, this is 4 to the power minus 2. Sorry, 4 to the power plus 2. 8 can be written as 2 cube. 4 power 0 is 1. This is 3 square. This is 4 square power minus half. This is 16 minus 3 into 4. If I give them their brackets, open the bracket, the power goes to both the numbers. So 16 minus 12 plus 3 power minus 1 upon 4 power minus 1. To make their powers positive, I swap them. So now LCM is 3, 12 plus 4. So 16 upon 3. Answer is 16 upon 3. Any doubts?
No, ma'am.
No.
No, ma'am.
These
ma'am.
were normal simplification sums, that numbers, and you have to simplify. Now we'll move on to a new variety where we have to simplify our power question. See, before moving to this, what is 5 power n into 5 square?
Ma'am,
5
5
power
power n
n
plus
plus
2.
2.
What will be 5 power n divided by 5 square?
5
5 power
power
n
n
minus
minus
2.
2.
So can I not write that if I have 3 power x plus 4, can I not write this as 3 power x into 3 power 4? Because the power was positive, so I can split them into multiplication.
Yes,
Yes,
ma'am.
Yes, ma'am.
If I have 3 power x minus 4, one thing is, since the power is divided, I can also divide them. Power is subtracted, so I can divide them.
Yes, ma'am.
Or what I could have done is 3 power x into 3 power minus 4. Even that would have been okay, I guess.
Yes, ma'am.
Yes, ma'am.
Any doubts?
Yes, ma'am. No, ma'am.
No, ma'am.
Now, same thing we are going to do here. 5 power n plus 2 minus 6 into 5 power n plus 1. 13 into 5 power n minus 2 into 5 power n plus 1. So let's divide all the powers. This n plus 2 can be written as this
5
term can
power
be
n
written
into
as
5 power
5 power n into
perfect.
5 power 2.
Next 6 into
5 power n into
5 power 1.
5 power 1.
Here I have no place to split. Here again 5 power n into 5 power 1.
Yes, ma'am.
Now what I'll do is I'll take these variable things common, both in the numerator as well as in the denominator. Taking 5 power n common, I'm left with 5 square 25 minus 6 into 5, 30.
Yes, ma'am.
Same thing in the denominator, taking 5 power n common, I'm left with
13. 13 minus 10.
perfect. 5 and 5n gets cancelled. So minus 5 upon 3. Minus 5 upon 3. Is it clear?
Yes, ma'am.
Yes,
Yes,
ma'am.
Yes,
ma'am.
ma'am.
Yes, ma'am.
Can you try? 2 to the power n plus 2. 3 into 2 power n plus 1. 2 to the power n minus 2 into 4 to the n and minus 2 to the power plus 2 to the power n. Right. Try this question. Do you have an answer? Okay. Let's see. 2 power n plus 2 can be written as 2 power n into 2 power 2. Then
Yes.
minus 3,
Yes, ma'am.
2 to the
Yes.
power n into 2 to the power 1.
Yes, ma'am.
4, 2 power n divided by 2 power 2.
Yes.
Yes, ma'am.
Plus 2 power n. Now this 4 and 2 square gets cancelled.
Yes, ma'am.
In the numerator, taking 2 power n common, I'm left with 2 square 4 minus 3 into 2, 6. And in the denominator, if I take 2 power n common, I'm left with 1 plus 1. Is it not?
Yes, ma'am.
So 2 power n gets cancelled. Minus 2 by 2, that is minus 1.
Yes, ma'am.
Any doubts?
No,
No,
ma'am.
ma'am.
No, ma'am.
Clear?
Yeah, ma'am.
Yes, ma'am.
Yes.
Yes,
Now,
ma'am.
for powers, if I want to compare them, for example, I have cube root 2 and I have square root 3. What I want to know is which one is larger. If I would have written instead of this square root 2 and square root 3, we would have known directly which one is larger. In this example, which one is larger? Square root of 2 or square root of 3, which number is larger?
Root of 3, ma'am.
Root of 3.
Yes. Why did it take you so much of time? 3 is more than 2, so their square roots will also be more. But this can't be said here. Why? Because there are different powers. Here it is 2 to the power 1 by 3, and here it is 3 to the power 1 by 2. So right now I can't compare, yes? But if the power would have been same, then it was easier for me to do. So what I want is to make their power same. Here I have 3 in the denominator, here I have 2 in the denominator. What is the LCM of 2 and 3?
6.
6.
6.
ma'am.
So here it is 6. So 1 by 3, if I've written as something by 6, that means I multiplied 3 by 2. So the numerator also has to be multiplied by 2. So it will become 2 by 6.
2 by 6.
What will be this be?
3 by 6.
Multiplying both numerator and denominator by 3. Any doubts?
No, ma'am.
No,
No,
ma'am.
ma'am.
Now taking 1 by 6 outside, I'm left with 2 square,
Yes, ma'am.
Yes,
4
ma'am.
power 1 by 6. Here I leave 3 cube and I take 1 by 6 outside. So I'm left with 9 to the power 1 by 6.
Yes, ma'am.
Now out of them, which one is larger?
9.
9. So automatically, since this is larger, so cube square root of 3 is more than cube root of 2.
Yes, ma'am.
Yes, ma'am.
Any doubts?
No, ma'am.
No,
No,
ma'am.
ma'am.
All
No,
of
ma'am.
you?
No, ma'am.
No, ma'am.
No.
Okay. So today we first talked about indices exponent. We talked about their formulas and we did three varieties of questions. Any doubt from any of the questions?
No, ma'am.
No.
Okay. Then we shall continue in our next session.